Alright, let's take a look at my solution for molecular foundry. Look at this beautiful solution. So many pipes. This is the brute force method right here. If you find that you're getting backed up, so you see you get, okay, so let's start from the beginning. The inputs, iron oxide, carbon. I don't know why this carbon is in a different orientation. It seems needless. Anyway, and you have to make cementite, which is a steel. They harden it in some way. Anyway, so basically you get 3 times as much iron as you do carbon. All you need is iron and carbon. You can throw out the oxygen to this recycler. And it's tough because the iron gets backed up. The way I did it, I can't use the iron fast enough, so I was getting backed up with the iron. Wasn't getting enough carbon, so I just extended the pipe out forever to solve that. And because you need 40 of this, and it takes forever, so I actually needed almost all of this pipe in order to get there before it backed up all the way and broke my reactor. Alright, so let's start from the beginning. All this does is breaks this apart. The red one just grabs the central atom and recycles it. So unfortunately I lose a carbon here because this is 3 carbon and I only get 2 of them. And I think if I could have figured out how to get all 3 carbon, then I might not have gotten backed up, but I couldn't figure that out. And it works this way, so I just stopped as soon as it worked and I didn't bother to tweak it at all. So this is pretty straightforward. Takes out the carbon and the iron, and that's about it. Just gotta break each one. There you go. So that gives us carbon and iron. All this one does is discriminates them, I guess, segregates them, whatever you want to call it. Iron goes in the top, carbon goes in the bottom, and that's really easy. That's straightforward. This blue guy's not doing anything. So that's that. As you can see, they haven't gotten there yet, but there's like 10 irons and like 4 carbon, so I mean, you use carbon so much more quickly, or you can't use carbon quickly enough. So here what I'm doing is bonding basically 1/3 of the cementite. So the cementite is just, the way I looked at it was 3 rows, so you got carbon, iron, iron, carbon, iron, iron, carbon, iron, and they alternate, so the middle one's facing the other way. So although this one faces left, the carbon's on the left. So this one's pretty complicated too, I guess. You gotta bond the 2 irons and then bring in the carbon and send it out. So here comes 1 iron, move it over. Here comes the 2nd iron, bond it, move it over, bring in the carbon, dump it out. There you go. So this is 2 loops for the blue guy, pretty much. Actually, it kind of looks like 3. I don't know what's going on there. Anyway. Here we go. This is where it gets pretty complicated. So what I did here is I brought in, let's see here. So on one loop, I bring in the string there, the row, and I just dump it off for the red guy. The red guy holds onto it. Bring in the second one, rotate it so that you've got that alternating pattern. Drop it off, and then bond, 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 and then send that out. So now I've got 2/3 of the cementite. And you get a little bond, sync, bond, and then you only need to use these 2 of these bonders here to do all that right there. Since the rows already bonded together, so all you need to do is bond the 2 rows together. And let's see if we can get another one here. So bring it up, leave it for the red guy. Red guy takes it, leaves it right there, and then you bring in the second one, rotate it, dump it off, bond, bond, bond. Dump it out. So this is the one I'm pretty proud of right here. So we'll skip ahead so it starts over. So what this does is, this is pretty complicated right here. Actually, this didn't take me all that long to work out. I was really surprised at how well it worked. I thought for sure I'd have to do way more bug fixing and all that than I had to do. So the way this works is I bring in the 2/3 cementite, which takes forever, but get one eventually. There it is. So bring this in, and then I'm going to break it up, and I'm going to put it back to 1/3, and I'm going to dump the other third to the recycler. So this guy, so I'm going to stay here, unbond, unbond, unbond. Red guy grabs it, recycles, and then blue guy is going to hand it off to the red guy. right there. So now the red guy's got it, and the red guy goes on his second loop of the whole circuit, and he's going to hold it right here. And he's essentially going to do the exact same thing that I just did, except with plus bonds instead of minus bonds. So I'm going to bring in the 2/3 again, and this time I'm going to bond it to the 1/3, and 2/3 plus 1/3 makes 3/3. So there we go. So here we go. Same thing again, sync bond, bond, sync, and that's pretty much that right there. So now this guy's got it, and you can see these were double bonded because of this right here, and it's supposed to be single bonds all over. So that was actually an easy fix. There's just a couple minus bonds right here, and then these extra bonders right there. So as it passes by, it unbonds itself. It's back to one bond, and bam, dumps it out. And so that's that. It works. It takes forever, but it works. I mean, if I went back to this, I would definitely change some stuff. Like, I barely even used the super bonders. So you get the super bonders, which have 8 bonding units. In the first one, so I used 3 of them. This one, I use these 2, and that's it. These are just lying around. This one, I use these 2, and the rest are just lying around. And then this last one, I actually used 5. So this is the only super bonder that actually acted as a super bonder. So I use these 3 right here, and then these 2 to unbond. And that's that. So, I mean, as you can see, here's all the iron getting backed up. It gets down to like right here before I win. So it was a pretty close call, but this one actually didn't take me that long, and I was really proud of it. And there you go. See, I took way more cycles than most people did. But it worked, and I liked it. So there it is.